Hi there and welcome to this video overview on oil and gas, power plant and industrial facilities engineering. It's based upon a video done by Herve Baron on oil and gas engineering. A link to that video is available in the description. So we begin. So we'll be focusing on a few topics. This is the introduction and part 1 of this video review on oil and gas engineering. These different sectors have been grouped together because they are basically of the same in terms of scale and magnitude, so the stages involved in each of them is similar. So first of all, we'll be looking at the stages of oil and gas project management. As we go on, I may drop one of these terms, either oil and gas, power plant or industrial facilities. I may use only one of them. So just remember that we are talking of all three types of facilities. So we'll be looking at project management viewpoints, conceptualization, actual project design, discipline engineering and design, FEED documentation, engineering procurement and construction. We are going to finally conclude on this, then talk about the next step of this tutorial and review. So you see, basically in the oil and gas project management stages, we have basically 3 stages. Although in project management, you typically, depending on the standard you follow, typically you are going to have 4 stages, which is initiation, planning, execution, and completion. Some cases they may want to have 5, which is initiation, planning, execution, completion, as well as commissioning, depending on the scale of the project. But for most of these facilities, it's broken down into 3 stages. Step 1 is the initiation or conceptualization stage. Stage 2 is the, would I say, planning, although some design takes place here, but we call it step 2, which is the planning stage. And step 3 is sort of like the all-encompassing. It's like it includes a part of planning, execution, completion, and commissioning in most cases. So there are some key terms that need to be understood for this case of oil and gas project management. You have the FEED and you have the EPC. FEED stands for front-end engineering design, while EPC is engineering, procurement, and construction. These terms will be explained as the video progresses. So in terms of step 1, which is the conceptualization stage, basically it's based on the company's strategy and the need of the society. So most companies are in business based on what they want to do personally in terms of their achievements, their long-term goals. And also you cannot just be working based on your own personal goals. You also need to look at the environment as to what the society actually needs. So these are 2 main factors involved when companies want to embark on any particular project. So in most cases, during the conceptualization stage, several projects are going to be put forth and proposed and placed on the table to be embarked upon. So among these various projects, certain criteria and metrics will be used to screen them down. Maybe you start with like 10 projects and you use various metrics, maybe probably the cost, the distance, the return on investment, the payback period, how much issues it actually solved. All of these are quantified using project management standards, and a sort of like selection is used to pick out the project that best perform based on all the metrics that have been put together. So from this, you are able to select one project. It may be 2, but typically you are talking about one project, and this is where the business case is born. So it tells you the capacity of whatever facility you want to construct. Let's say you want to, you're going to be extracting oil. So you're talking about how many barrels you intend on extracting per day, whether it's onshore or offshore. So the number of barrels per day, you can actually determine how much storage facility you need on the platform, or the size of the platform, and other such information. So those key details as to the number of barrels per day, the available storage in the location, as well as how long you want to exploit that location, as well as the revenue coming from there, are some factors that determine the size and leads to your business case. So from the business case, you take out this information and apply it into the step 2, which is the feed, the front end engineering design. So the output of business case from step 1 is used in the front end engineering design. So typically this feed term, for those who are new to oil and gas engineering, is a term that is used most of the time because the field is quite complex, so you can't be using long terminology all the time. So it's best to use this acronym. So the need for feed. So you see here, most times the feed is done in-house by the organizing company that intends on investing in a particular field of the business. So you will see that several designs will be done. Probably they will also research the project archives in the company and see what information can be taken from there, as well as get information from other experts. At this stage, there's some level of design. It may not be finalized design, but there's more rigorous design compared to step 1. So this information is now gathered together, and the output, the design documents which are approved, are now the output of this step 2, or the feed stage of the project. So coming here to step 3, which is the EPC, as previously defined. The input into the EPC stage is the feed documentation. So in the EPC stage, you are talking of execution, procurement, although procurement may actually occur before the execution, depending on the nature of the project. There are some projects that require that you send out documents based on the feed analysis. You send out documents for contractors to bid and send in their own proposals. So they will look at what the purchasing company has requested, and they will provide their own technical analysis and expertise, as well as the cost as to how it's going to be achieved. So these are some things that may be done in this EPC stage. In some other cases, probably the organizing company has already carried out all the necessary design to its most accurate detail. Then you just bring in a contractor to come and carry out the execution and construction. Even in this case as well, there is still going to be some procurement, because after your feed design, when you get into the construction stage, there is a lot of material and equipment that need to be brought in, some of which take more than 6 months, 9 months, a year, probably even 2 years. So this is a major stage in the project. So all of it, from the execution to from major planning, execution, completion, and commissioning, are all put together into this step 3 in oil and gas project management. So basically there are several viewpoints, but I narrow them down to 2 basic viewpoints in project management, one of which is top down and the other of which is bottom up. With respect to top down, we are looking at it with a bird's eye view understanding of the project. For example, people who have been in the field for so many years, they have experienced so many projects that they know. Let's say if you build a platform of 100,000 barrels per day and a platform of, let's say, 75,000 barrels per day, or let's say 10,000 barrels per day, they actually know how much it costs for, let's say, a fixed offshore platform. They knew how much it costs for the 100 barrels per day and the 10,000 barrels per day and 100,000 barrels per day. They knew how much it costs. So at that level, they are able to make decisions as to how much is typically going to cost for a 50,000 barrels per day facility. So that's looking at it top down. With respect to bottom up estimation, is based on when you have more rigorous design calculations. Then you're able to know on this facility, these are the number of pumps we are going to use, these are the number of turbines we are going to use. That's in the case of a power plant facility. So you can actually count it, and let's say you have a turbine of 25 megawatts. You know how much a 25 megawatt turbine is, and let's say you need 5, or let's say you need 4, which is about 100 megawatt facility. So you can actually count the number of turbines you need. So that's how you go from estimating the piping to the pumps to the turbines and other similar facilities, probably the vertical vessels and the storage facility. So this is also explained in this picture, where you have the top photographs showing industrial facility, offshore exploration facilities. So that's a bird's eye view, because there are so many components, you cannot be picking them one after the other. But looking at the picture below, where you have a more controlled environment, you have vertical vessels, storage vessels, you have pumps, and you have pipes, all of which can be estimated. So looking at a detailed level is the bottom-up approach, and looking at it from a bird's eye. So in step 1 of the project management of oil and gas facilities, the approach to use in estimating both the technologies and as well as the cost is the top-down comparison. So we will have to look at similar projects to what we actually want to embark upon. If it's a fixed offshore platform, probably a floating storage system, whatever facility it might be, you have to look for something that is similar to it, and then estimate based on that both the technologies, the storage facility, such other factors similar. It's based on something similar. So if you are now looking at a project that has never been done before, then you have to break that new project into smaller components, and then look at the closest project that is similar to each minute component of that large new project that needs to be embarked upon. Because not all projects are existing. Some projects may be new innovations that have never been done before. However, every project can be broken down to a manageable component. So in terms of top-down estimation for the cost estimate, it's possible to use, let's say you have a facility that is situated upon, let's say, 1,000 square meters, and you have another one that wants to be situated upon 10,000 square meters. So you could say, oh, we are going to use a proportion of times 10 for the costing. That approach may be crude because the margin of error may be much higher. But if you look, there are various methods for proportion, algebraic or multidimensional metrics. For example, it could be that you're using several attributes of the similar facility that you want to compare to get your own estimate. For example, it could be that you're using the floor dimension, you're using the height, you're using the number of equipment, probably the capacity, and several other factors. There are also equations that can be used where you place one as the numerator and the denominator, and the power factor is used to estimate the likely cost of this other project. So these are some ways to do top-down estimation for oil and gas projects when you are in step 1 stage of the project. So in step 2, you'll be looking at actual project design. This is more rigorous than step 1, but it's less rigorous than step 3. In this stage, the bottom-up comparison is going to be used for estimating the different equipment that are required. Like stated before, if you know the capacity of your facility, probably 100,000 barrels per day, or let's say a power plant, you want to generate 100 megawatts of electricity in terms of capacity, you then know how much, you then already know the size of storage for an oil and gas facility, and also you know the size of the turbines you are going to be using for a power plant facility. So from there, you are able to estimate this is how the facility is going to look like based on similar projects that already exist. Also, with respect to the estimation, it's much easier because you know the number of equipments that are required in each case, and then you can estimate based on that. And from there, you'll be able to come up with the overall project cost with some tolerance to allow for market variation. In most cases, the error margin in this stage, bottom-up estimation, is around plus or minus 10% of the real cost of embarking on this project. So in the step 2 stage of this project, there's going to be the involvement of various experts. During the field analysis, you have a project manager coordinating various professionals, and these professionals come from various backgrounds. You have them from mechanical, civil, architectural, structural, electrical, instrumentation and control, and procurement. At various levels of the field design, different engineers are involved in the project. For example, you may not have a civil engineer carrying out this design until probably the mechanical engineer and some other experts would have done the process flow diagram, the single line diagram, as well as some layouts to enable the civil engineer to actually do an overall general arrangement of the facility. So at each stage, different experts are called upon to carry out their own aspects of the design. Along the line, there may be some conflict because sometimes you may not get the information at the right time, but you are requested to implement on site. So that's where the project manager comes in to coordinate and ensure that there is a streamline and good coordination amongst the different disciplines of engineering. So at this stage, there is intense design compared to step 1. There's more design here, which is carried out by the various experts in the profession. So in the field stage of project management, there's going to be several design that will be carried out by different engineers, and at each stage there are going to be changes from different engineers that may affect the drawings from other units in the project management of the project. So there is a convention because there are so many drawings, you cannot just give them a name and leave it that way. There is convention that is similar to what we have on the screen here, but each company is going to have their own standard which they have already created. So it's good to check the organization culture and assets, as well as enterprise environmental factors, which are some key information and standards in project management. So a company always has their own documentation standards which you can always look at. So typically in most standards, documentation can be based on the title, a number, maybe an alphabet to indicate maybe a unit or which discipline is responsible for it. You also have the revision number. For example, a drawing may be worked on 3 times, 4 times, 5 times. So you always need to indicate that it has been revised on this particular date and it is indicated on the document. This is helpful because when a person wants to carry out, maybe you want to make comments, you want to have a meeting, you want to be sure that everybody has the latest version of the same documents. So you don't go ahead and be reinventing the wheel or having conflict in discussion because people are having different documents in their possession. So the EPC stage of this project is sort of like capping off the stage 1 and stage 2. This is where majority of the works are carried out, and you can see here the various details are set forth by Herve Baron in this video, oil and gas engineering guide. In step 1, you see that the level of detail creates some amount of error in estimation of the cost. So you can have up to like, let's say you have up to like minus 30% to up to plus 50% in error. Although here they have placed 30%, but there are some projects that can actually be 50% higher than what it was estimated to be. So as stated before, for step 2, where they have more rigorous calculation, is 10% plus or minus an error in estimating the cost. So we have gotten to the end of this video. So this is a brief overview of what has been discussed in this part 1 of this video review on oil and gas, power plant and industrial facilities engineering. So like we stated earlier in step 1, which is the conceptualization stage, the input into this stage is the strategy and the business need, and the output is what you get is the business case, which is then used as an input in the step 2, the feed stage of the project. And in this case, we use the business case to carry out the design, and the approved documentation is now the output from step 2 and is used as an input into step 3, the EPC stage of the project. Looking at this, the next steps is going to be further discussion of the various disciplines of engineering in terms of what they do and their own aspects and responsibilities in handling the project. So see you in the next video. Aqua Delta Tech, where we create for better living.